Hello, dear students. Welcome to the next lesson. Till now, you have learned the art of handling this wonderful machine called computer. You must have noticed how user friendly the machine is, isn't it? You can listen to the music of your choice. You can play the movie of your choice anytime, anywhere with DVD or VCD. I hope you remember what DVD and VCD means. Please recollect. In my earlier lessons, I taught you some important abbreviations such as DVD and VCD. Yes, you are right. DVD means digital versatile disc and VCD means video compact disc. Today I shall begin by teaching about a few television standards followed by various countries. Let us start with our own country. Yes, in India, we follow PAL system. PAL stands for Phase Alternate Line Analog Encoding System. This is used in our country and UK, United Kingdom. NTSC is the second system. It stands for National Television System Committee, and this standard is used in North America, Japan, South Korea, Taiwan and Burma. CCAM is the third standard. It stands for Sequential Color with Memory System, which is primarily used in France and a few European countries. Now I shall take you to the magical world of computer graphics, our today's lesson. Computer graphics means visual computing, where you utilize your personal computer to generate visual images synthetically. Additionally, you can integrate visual information and spatial information sampled from the real world. There are several areas which we will cover in the lesson to understand computer graphics. These are real-time rendering used in video games, computer animation, video capture and video creation rendering, special effects editing used for movies and television. You must have seen the latest movie Avatar. The movie which is full of computer graphics and animation. Image editing and modeling are used for engineering and medical purposes. Now let us see the historical background of this exciting field. The first major advance in computer graphics was the development of the sketchpad by Ivan Sutherland in 1962. The first use of computer graphics was in an animation film named Future World in 1976, which included an animation of a human face and hand. The film was produced by Ed Catmull and Fred Park at the University of Utah. The first film to use computer graphics was 2001: A Space Odyssey, which attempted to show how computers would be much more graphical in the future. However, all computer graphics effects in the film were hand-drawn animation. Now let us see what is two-dimensional computer graphics. There are two approaches to two-dimensional graphics. One is vector graphics and another is raster graphics. Vector graphics stores geometric data, topology and style such as coordinate positions of points, the connection between points to form lines and paths and the color, thickness and filling of the shapes. Circles and rectangles can also be used in vector graphics. Vector graphic image has to be converted to raster image to be viewed. Raster graphic is uniform two-dimensional grid of pixels. Each pixel has a specific value such as brightness, color transparency, etc. A raster image has an infinite resolution of specific number of rows and columns. Your computer displays show a raster image of resolutions such as 1280 columns and 1020 rows of pixels. Combination of these two creates file formats such as PDF and SWF file, which you must have heard. I shall take a separate lesson to teach you about various file formats. Now let us look at the computer graphics in three-dimensional. Three-dimensional graphics is based on vector graphics. Instead of the computer storing information about points, lines and curves on a two-dimensional plane, the computer stores the location of points, lines and faces by constructing a polygon in three-dimensional space. 3D polygons are the heart of 3D graphics. Most 3D graphic engines are based around storing points in single three-dimensional coordinates and lines that connect those points together and faces between the lines, and finally a sequence of faces to create 3D polygons. I hope you understand this. Nowadays, massive collection of polygons are converted into recognizable shapes, scenes and models. Now, we will learn about the shading, texturing and rasterization. After modeling the characters and scenes as I described you before, to work on their visual look and feel, the process of analyzing, designing and applying the visual look and feel is called shading or texturing. Now, let us understand what is shading. The process of shading involves the computer simulating or calculating how the faces of a polygon will look when illuminated by virtual light source. The exact calculation varies depending upon the data about face to be shaded. Okay, now let us learn something about image-based rendering. Computer graphics is obtaining 2D images from 3D models. To get highly accurate and photorealistic images, the input three-dimensional models should be accurate in terms of geometry and colors. Simulating the three-dimensional world scene using computer graphics is difficult. Why? Because to obtain accurate 3D geometry of the world is difficult. Image-based rendering helps us use the images taken from a particular viewpoints to obtain new images from other viewpoints. On the basis of research named computer vision in 1996, two image-based techniques were developed: light field rendering and lumograph rendering. Thereafter, machine learning concepts for image-based rendering were developed. Let us discuss a few of these techniques. Flat shading is a technique that shades each polygon of an object based on the polygon's normal and the position and intensity of a light source. Guard shading is a fast and resource conscious technique used to stimulate smoothly shaded surfaces by interpolating vertex colors across a polygon surface. Okay, let us learn now about texture shading. It is a technique for simulating surface detail by mapping images onto polygons. Fong shading is a smooth shading technique that approximates curved surface lighting by interpolating the vertex normals of a polygon surface. There are other concepts also, such as bump mapping, ray tracing, radiosity and blobs. Now let us learn something about renderer. Renderer is a program responsible for converting geometry and scene elements into final images. Let us discuss some of the most common renderers used in three-dimensional computer graphics. Scanline renderer is a default renderer. In spite of the fact that the results of this renderer are good, it does not compute illumination and radiosity, the lighting techniques which result in natural and photorealistic renders, which requires global illumination computation program. Mental Ray from Mental Images, Germany is one of the most sought after renderer because it involves a lot of reflections, refractions and complex lighting setups. It also supports radiosity and global illumination and is widely used for film visual effects worldwide. The same has been used in Avatar movie also. Chaos Group's V-Ray is also an excellent global illumination and radiosity renderer. Easy to use and is stable and provides excellent render output with least possible effort. To work on shading and lighting, dear students, you will have to develop your observational skills like artists. So, to begin with the task of shading, observe a real world object and analyze the following elements. The first element is the color. It defines the exact color of the object. Then shininess is the objects shine, as you know, and are glossy, and this property is called specularity. It can help you design a lot of things. The next thing you must observe is roughness. It defines the roughness of an object. For example, a brick is rough, but silk is not, isn't it? The next element is reflectivity. You know, polished surfaces reflect. For example, mirror reflects, but a wood does not reflect. You must observe these elements. The next one is refractivity. How much the light beam bends upon entering a medium measures the refractive index of the medium. For example, you see a distorted vision when looking through a glass or a lens. The next element is translucency. When light beam scatters inside of a surface, for example, while light beam travels through wax or marble or milk. The next element you must observe is self-illumination or incandescence. As you know, a filament in a bulb glows due to self-illumination, or a blinking LED is also self-illuminated. Now, with this knowledge of the elements which I just described, the task of becoming a shader for you becomes very easy. Now, let us learn something about texturing. You know, polygon surfaces are the sequence of faces which contain data corresponding to color, virtual canvas for a picture. Such an image is placed onto a face or series of faces and is called a texture. Now, having learned the basics of computer graphics, I shall show you short video films using computer graphics in order of their complexity. Now, we will start with the simplest Man Ki Aankhein, another very short computer graphic film.
चींची की जब नजर पड़ी तो झट से आई पास, बोली क्या हुआ चकमक?
इस बार भी मैं फेल हो गया, लगता है मैं कभी पास नहीं हो सकता।
पास हो सकते हो अगर तुम्हारे मन की चिड़िया ठान ले।
मन की चिड़िया?
हाँ, हम सभी के अंदर एक छोटी सी मन की चिड़िया होती है जब तक नहीं उड़ाए इसको छुप के बैठी सोती है। जो इसकी ताकत पहचाने वो भरता है नई उड़ाने।
वो भरता है नई उड़ाने। समझ गया।
The walkthroughs of the malls at Gurgaon and Noida are really amazing. I am sure you will not only enjoy these videos, but will get motivated to create one of your own. Go ahead and sharpen your observational skills and get into the world of computer graphics. All the best. Thank you.